Hi guys, welcome to a new unit. We are going to start trig today. So the first thing is I'm just going to run through some of the vocab. So when it's saying when you draw an angle, it has an initial side and it has a terminal side. All right. Initial meaning where it starts, terminal meaning where it ends. Right. When we draw in standard position, it means that the vertex is at the origin. Right? The initial side always starts on the positive x-axis. So I'm going to come down to the graph here, and let's start under where it says degrees. All right. So under degrees, I'm going to draw an angle where the vertex is always right at the origin. We're going to start it right on the x-axis. So this is the initial side, or sometimes called the initial ray. Right? And then with the idea of how we're going to draw angles is we're drawing them as rotations. So let's use an example of 120 degrees. That makes an easy one to start with. Right? So 120 degrees, you guys know it's obtuse. You can kind of eyeball what that would look like. So maybe something like this, right? Where that's the 120 degree angle. So a few things. Over here, that makes this the terminal side, because that's where the angle stops. Right? And we think about it as a rotation, starting in or on the x-axis and then rotating up and open to that angle here. One vocab term that gets brought up every now and again is called coterminal. So if you think about that you're sharing that terminal side. So an example, if I had an angle that is coterminal with the angle that we just drew, maybe I would rotate the opposite direction. So maybe I would rotate going this way and stop at that same point, right? So much like when we did transformations back in geometry, right, we follow the quadrants. So if I think quadrant 1, quadrant 2, quadrant 3, quadrant 4, anytime I'm rotating in a positive direction, I would follow that order. So 1, 2, 3, 4, following the quadrant. I think if I go 120 in the positive direction, I would have to go negative 240, right, in the reverse direction to match up that full 360 there. Right? So those would be examples of coterminal angles. The last part, a quadrantal angle. Quadrantal angle is just any angle that the terminal side falls on the x or the y-axis. So when you think quadrantal angles, they have to be multiples of 90. So starting on the x-axis, that would be a 0-degree angle if the initial and terminal side were right here. Up top would go 90. Over here would go 180, 270. This would bring you right back to 360. And then you can keep going because it just means that you would have more than one rotation. Right? So angles that are bigger than 360, whereas in the past it might have seemed weird to try to draw it, now I want you to think of it as a rotation. Angle rotation, if it's a positive angle, starts at 0 or 0 radians, and it's going to rotate counterclockwise. But I always like to think of that as it follows the quadrants. Right. And then if it's a negative angle, it just means that you're rotating in the opposite direction. So you're going to go clockwise. So first of all, radians, specifically, this is a unit of measure for angles. So the same way you wouldn't measure like your height in degrees, that doesn't make sense, right? You don't measure angles in inches. You measure it in either degrees or in radians. And the definition is that 1 radian is equal to the angle that intercepts an arc length equal to the length of the radius of the circle. So I've already pre-cut these little wiki sticks, so I'm going to lay it down. And you can see that the length of it matches the length of the radius right there. All right. So I'm going to take my wiki stick off, and I'm just going to kind of highlight over to show, okay, here is my radius. So if I take that same Wikki stick and I bend it, that's the beauty of this. This can also be done with string. It's just a little bit harder to get string to hold in place. The Wikki stick sticks, so that kind of helps there. That little spot where it hits, I'm going to mark that on my paper. And then if you have a straight edge available to you, this is a great time to use it. Maybe I'll just use my little notepad here. I'm going to line that up with the center, and I'm going to draw that angle in. All right. That right there, that angle is equal to 1 radian. And the cool thing is, if I make it a bigger circle, the radius would get bigger, and therefore it stays the same radian measure because it would essentially just be proportional figures. Right? I won't go full geo on you, but that's the basic idea. Right? So I'm going to take this off and I'm going to highlight where that Wikki stick just was. That length right there. That's the length of 1 radius. All right. So since this is congruent to that, that's how this becomes 1 radian. And that's kind of where the name comes from because it matches the radian length there. All right. So when it says, how many radii can we fit around the whole circle? Like I said, if you remember this activity, you might have then picked it up and said, all right, well, let me move it around and see what we can do. So we can mark, there would be 2 of them. And then I can come back and mark again. So there's 3 of them. So if you look, 3 is not quite half a circle. So a little bit more than 3 would be, you know, that 180 mark. And now if we keep going, here is 6. And then we've got a little left over. All right, so you still have this little remaining extra part. So when it says how many radii can we fit around the whole circle, you know, 6 and some change. So when the next question says, what's the distance around the circle known as? Right, what I mean by that, when you think about, all right, well, what is the distance around the circle known as? Well, that's just the circumference. And when you think back to geometry, I'm going to switch back to my blue pen here. Circumference can be written 2 ways. You could write it as pi d, or you could write it as 2 pi r. And so if you think about what that means, is the formula that you've always learned was trying to tell you how many times the radius can fit around the circle. If we think about 2 pi times the length of the radius, 2 pi itself, well, we know what pi is. It's about 3.14. So if we double that, it's about 6.28 approximately, right? Times the radius, which what that means is you should be able to fit in 6 full radii all the way around, plus about 0.28 of another one. So a little more than like a quarter of that length. So you can fit about 6.28 radii around the circle. How cool is that? Right? That's what that formula actually means. So the last part, how does that help us go from degrees to radians? Well, I want to go back to the idea, oops, I'm a little crooked on you here, all right, of what is the distance around a full circle. Well, in terms of degrees, full circle we know is going to be 360. Well, what is it in terms of radians? Think about the formula we just used. We said the full circle is 2 pi times the radius, right? Well, for each radius, that equals 1 radian. So the number of radians around the full circle would be 2 pi of them. Right? So 360 degrees is equivalent to 2 pi radians, which sometimes I'll abbreviate just to rads there. Right? Well, we can use that as our conversion factor, but I want to take it one step further. I'm going to divide it by 2. So what I want to have it as is 180 degrees is equivalent to pi radians. This is our conversion factor. And think about it like 12 inches is equal to 1 foot. Same type of conversion. So if you're converting from feet to inches, that's what you use. Here, we know that for every 180 degrees, that's equal to pi radians. So 3 and some change radians, right? Which makes sense because when you come back up here, we are able to fit 3 radii plus a little extra in the same space that 180 degrees took. With that being said, go back to the front now. So back on the front of the notes, let's draw in, and let's actually use the quadrantal angle as our example. So this would be 0 right here. And now we just said that 180 is the same as pi radians. So if we go full 360, that's the same as 2 pi. And now think about logistically, if I went from 0 to 180, half of 180 was 90. Think about what half of pi is. Well, that would just be literally 1/2 pi, or we'll write it as pi divided by 2. So this is 0, half of pi, a whole pi. Think about what this is so that we get all the way to 2 pi. This would be 1.5 or 3/2 pi. And then we could keep going. So what I'd like you to draw over here is an example. And we'll use just pi over 2 radians because that's a quadrantal angle. So you can just draw it so that it falls right on the y-axis. So here's your initial ray, your terminal ray, and that would be our pi over 2 radians right there. So I want to start with degrees because I think we're probably more comfortable with that, and then we'll work our way into radians. So a couple quick ones. So if we do 300 degrees, the easy part, you know approximately what that looks like, but I want you to start by giving yourself a set of XY axes, and I always want you to put the initial ray right on the x-axis. So if you have a colored pen or pencil, this is a great time to use it. If not, you can just stick with what you have. But here's the initial ray, always starting at 0, because it's positive 300 degrees. We're going to rotate following those quadrants. So it's going to go from here. Think 90, 180, 270. So you're going to go a little ways past that and draw that terminal ray. That would be 300 degrees. And if it helps, you don't have to label these every time, but sometimes it's good as a little reference there. So the angle is actually this piece of it here. So if we do one more, let's do a negative angle measure. So let's say negative 500 degrees. So set yourself up, give yourself a set of axes, and then it might help to label it, but label in reverse. So still start at 0, and your angle's still going to start in that standard position. And then think, if I rotate clockwise, this would be negative 90, negative 180, negative 270, negative 360. And if you start getting lost, just keep subtracting 90, negative 450. And then when we get up here, this would be negative 540. So what the heck does that mean? That means I've got to rotate and stop somewhere in between here to hit 500. What I do want to see is I want to see the actual path of your angle rotating all the way through. So I should see that little spiral as part of your drawing. And then we can say it stops down here. That would be negative 500 degrees. So please show that work when you're doing the homework, when you're taking the notes. All right, let's do a few that are radians because this is the newer stuff. So for the first one, if we do pi over 4 radians, how we can think of this, give yourself the set of axes. And now I want you to think about the radian measure. Always starts 0. That's the easy part no matter what. And then pi is the same as 180. If what we are trying to do is take pi and break it up into 4, I literally want you to take that straight angle and break it up into 4 parts. So think about this big angle being broken into 4 parts. The y-axis is a natural divider, breaking it into 2 parts. And then I would have each quadrant there broken up so that here would be 1, 2, 3, 4 parts. Right? So when I have pi over 4, I'm going to use that denominator to tell me how many parts to break that straight angle of pi radians up into. So I'm going to write it as break pi radians into 4 parts. Now here's the easy part. How many parts do we look at? Well, in this case, the angle is pi over 4. So what's the number in front of the pi? Well, if I don't see it, it's just a 1, which means I'm only going to keep one of these little angles here. So start with it as the x-axis, and then I would only rotate up through one little piece of it. That is what pi over 4 is. So the 1 in front means I'm just going to keep one part for the angle. And now if you're thinking, I'm not sure I get this, give yourself the benefit of the doubt. Try another one before you've decided that you don't understand it, because it helps to see a few before it starts to click. So I'm going to make sure you can still see that one, and I'm going to do another one beneath it. Let's keep it simple. Let's stick with 3 pi over 4 radians. Why I think this is a simple one is because we're going to set it up the same way. So here's 0, here's pi. Because we're looking at 3 pi over 4, I just want you to focus on what pi is being divided into. So same as last time, we're still breaking up pi into 4 parts. So I want you to give yourself the exact same little division here. So the y-axis already serves as kind of one little way to break it. And then you can break quadrant 1 and 2 so that I get the same 1, 2, 3, 4 angles. But this time, now you've got a 3 out front. So what does the 3 mean? Well, the 3 in front means that we're going to keep 3 parts for the angle. So start at your x-axis, and we're going to rotate through 1, 2, 3 parts of it. And that's where you stop and draw the terminal side. So when you can see the comparison between the two, it makes it a little bit easier to understand the approach here. 7 pi over 4 radians. So if I have 7 pi over 4, I still am starting with that same setup. So if you have some space here, give yourself set of axes. There's 0 to pi. I want to break it up 4 ways. So 1, 2, 3, 4. All right. The catch on this one, 7 is bigger than 4. So all that means is it's going to rotate beyond pi. Right? So to do that, I want you to extend your little breakups here. Extend that line, extend this line. And if it's 1, 2, 3, 4, then it's 5, 6, 7, 8. So the 7 tells me that I'm going to keep 7 parts. Remind yourself we're always starting on the x-axis with the initial side. And now you're going to rotate through 1, 2, 3, 4, 5, 6, 7. Make sure to include 7. Sometimes people get confused and think to stop there. I want to go through those 7 pieces. That's my terminal side. That's what my angle would look like there.